Right, so for number 1, let's see, we want to find a critical value. That's where the derivative is 0 or undefined, and we're only looking at this interval here. And we want to decide if it's a relative min or a max. Now in this problem they've given us the derivative already. So the derivative equals 0 when the numerator is equal to 0. And the derivative is undefined. Oops. When the bottom is equal to 0. So we have one of our critical values here. We solve this one. I'm going to add 1 on both sides. And then we just need to solve this trig equation. Where does sine equal 1 on the unit circle? Sine equals 1 up here at the top, and that is at pi over 2. And so we have x equals pi over 2. And since we are working on this interval, both of these are on that interval. And so those are our critical values. All right, so now we want to determine if it's a relative min or a relative max. Now, this is our interval, so we're starting at 0, we're stopping at pi, and we have our 2 critical values. We really don't care about this one, though, because it's the endpoint. We already have it. So we really just need to put a pi over 2 here. And what we're going to do is we're just going to pick a number between 0 and pi over 2. Now, you might be wondering how to do that, but I think of the unit circle. So 0 is here on the unit circle, pi over 2 is here, so something in between would be like pi over 4, for instance. So I'll go ahead and pick pi over 4. And then something between pi over 2 and pi would be something, pi is over here. So I would pick maybe like 3 pi over 4. Okay, so we just get to plug it into our function here and see what we get. So sine of pi over 4 minus 1 over pi over 4. And sine of 3 pi over 4 minus 1 over 3 pi over 4. And then from there you can use your calculators to figure out is it negative or positive, or you can use your knowledge of trig. In either event, both of these come out to be negative, though. So you have a negative here, and you also have a negative here. And so it's neither is the answer.
I'm going to right here, Mr. Bailey.
Okay. All right, so that takes care of number 1. Let's take a look at number 2. Number 2 says, we have this function here. It says find the value of k for which y has a critical value when x equals 2. And then we want to know if they're a min, max, or neither at that point. So the first thing we do is we're going to take our derivative of this expression. The derivative of that would be 2kx plus 4. And we're going to set that equal to 0. We're not going to make it undefined because it's a polynomial. Polynomials are not undefined. But we will plug in our 2 here for x. And that gives me 4k plus 4. So we can solve that. It tells us that we have a critical value when x equals 2, so that's why we're allowed to plug in 2 there. And so there's my k value. So now I'm going to go back to my derivative here, and I'm going to plug that negative 1 in for the k. And I have negative 2x plus 4. So here's my derivative now that I've figured out what the k is. All right, and then we can do our number line test. Now we already know the critical values at x equals 2. So we just need to do our number line test using this. So I would plug in y prime of 1 and y prime of 3. We'll see if we get, if you plug 1 in here, you're going to get a positive answer. And if you plug 3 in here, you're going to get a negative answer. And so we're going from a positive slope to a negative slope, and therefore at x equals 2, we have a relative max. And so we would say, since f prime of 2, well, actually, we'll say since f prime of x, and actually y prime of x, we know f on is prime. Since y prime changes from positive to negative at x equals 2, this is where we have a relative max. Okay. So all of this stuff over here is for finding the k value. Take the derivative, plug in the x they give you, and solve for k. After that, plug your k into your derivative formula so you can get your normal derivative without the k in it. From there, you're up for your number line test. Go ahead and take a look at number 3. Same process. So we're going to begin by finding k. After we find k, we're going to find our derivative. And after we find our derivative, we're going to do the number line test. Okay? So to find k, the first thing we're going to do is we're going to take this derivative here. Next, we're going to plug in the value of x that they give us, which is 1. Oh, actually, we're going to set this equal to 0, so we're looking for critical values. And all of this simplifies into 2k plus 1 over 2. And we're going to go ahead and keep solving that there. I'm going to minus the half on both sides. So I've got negative half is equal to 2k. And then I'm going to divide both sides by 2. And when you divide a fraction by 2, that's the same thing as just multiplying the 2 on the bottom. So you end up with negative 1/4 equals k. So there's my k. Alright, next thing I'm going to do is we're going to come back to our derivative formula now. I'm going to plug the k that I just found in there. So f prime is equal to 2 times negative 1/4 x plus 1 over 2 square root of x. 2 times a negative 1/4 is a negative half. You can leave right there. Thank you. So there's my derivative. So we found our k, we found our derivative, now we're ready for our number line test. Our critical value is 1. And we're going to pick a number less than 1. And I would say go ahead and plug in maybe 0 might be tempting, but I already know 0 is not going to work, because if you try to plug 0 into this, you're going to get undefined. We'd end up with 0 on the bottom if you did that. So I'm not going to do 0. So we need to pick something like a 4th. And then we're going to pick a number bigger than 1. Now you might think plug in 2. I'm going to plug in 4, and we'll see why I'm choosing to do that in a minute. All right, so let's plug these numbers in and see what we get. Let's start with the 4. I think that's a little bit easier. 4 times a negative half is negative 2, plus square root of 4 is 2, and 2 times 2 is 4, so it's 1/4. And putting these together, we're going to end up with negative 1.75. So we have a negative slope here, which means that we could probably expect to have a positive slope on the other one. But just in case, we better check because it's a possibility that it would be in neither situation. Now, this one's going to be kind of a pain in the butt because it's a fraction. Now, you might see why now I chose to plug in numbers that have 4s in them because we have to take square roots, and 4 has a nice square root. If you picked another number, you might not have gotten such a nice square root. This one turns out to be negative 1/8. The square root of 1/4 is 1/2. You just take the square root of the top and bottom separately. And 1/2 times 2 is 1. So basically, we're just left with 1 here. And then putting these two things together, we get 7/8, which is a positive. So therefore, this is your relative max. Okay. So since f prime goes from positive to negative at x equals 1, we have a relative max. Alright, so that's it for your FRQ. Hopefully that was helpful. See you guys later.